Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about number of paths problem. The explanation here is completely based on the assumption that we already have some basic coding knowledge. If you are not good at basic coding, please visit our website learningmonkey.in, take the course placement training for service-based companies, then come for the competitive coding. Coming to today's example, number of paths. So first understand the question. Given m by n matrix is there. So they are going to give you a m by n matrix. Our task is to find the number of paths from the top left to bottom right corner. If you want to move from top left to bottom right corner, how many different ways you can move? That is what we need to identify. With example, you are going to get clarity better. Let's take an example 3 by 3 matrix. From each cell, we can move either down or right. You are having only two options. From each cell, you can move either down or right side. See, 3 by 3 matrix. From here, you can move down or right side. Similarly, from this cell, you can move down or right side. From each cell, you can move either down or right side. So how many different possible ways are there? In a 3 by 3 matrix, 6 possible ways are there. We move right side, down, down. This is one possibility. Right side, down, down, right side. This is another possibility. See these dotted lines, two dotted lines are there. Those are two possibilities. This blue color line, one possibility. Green color line, another possibility. Black color line, two lines are there. There are two possibilities. Total 6 possible ways are there. Our output should be 6. But you need to maintain a time complexity of order of m by n and space complexity of order of n. We need to maintain that. So we are going to discuss multiple ways here, but these explanations will help you a lot in the way you have to think about the competitive coding questions. That will give a better intuition. This intuition is going to be helpful for remaining examples. Now coming to the solution, see, using backtracking, we can solve this using backtracking. When we discussed backtracking in design and analysis of algorithms, so we know that, see here, why we can go with backtracking means from here you are having two possibilities. Either you can go down or right side. If you go right, here we are having two possibilities. You can go down or right side. Down or right side. If it is down is there, you can go. Otherwise, right side. Until you reach the last position. See, backtracking goes like this. Starting position, down or right side. From here, down or right side. Keeps on going until you reach the last position. Again, track back. Again move to the next option, again track back, again move to the next option. This is how backtracking works, but it is going to take an exponential amount of time, which is not suitable here. That's why. And one more thing, one more important point we discussed, previous when we discussed the design and analysis of algorithms, most of the problems that can be solved using backtracking, if they are applicable to dynamic programming, go with dynamic programming. This exponential time can be reduced to polynomial time in dynamic programming. These points discussed in our design and analysis of algorithms, we are going to apply this. So whether we can apply dynamic programming or not, let's check if we can apply dynamic programming or not. So dynamic programming means this is, let's take an example 4 by 5 matrix. 4 by 5 matrix, divide this orange color matrix is a 4 by 5 matrix. In dynamic programming, we need to check the possibility of sub problems. This 4 by 5 matrix is a big problem. We have to check that whether we can divide this into a sub problems. Yes, it is possible here. See this 4 by 4 matrix, this blue color dot line, which is 2 by 2 matrix, means the 4 by 5 is divided into 2 by 2. Let's understand 2 by 2. How many possibilities are there? One possibility, two possibilities. You take any 2 by 2 matrix from this 4 by 5 matrix. The number of possibilities are 2 possibilities. Similarly, if you take 2 by 3 matrix, 2 by 2 is a sub-problem of 2 by 3 matrix. Yes. So how many possibilities are there? Here 2 by 3, 3 possibilities are there. So like that, if there is a possibility to divide our program, our entire total problem into sub-problems, and thus, so if that is maintained, then we can go with the dynamic programming. So how we are going to we are going to save that sub-problem values, and we are going to use that values. That is what dynamic programming means. So how we are going to use that, let's try to understand. Let's take 4 by 5 matrix, the same matrix 4 by 5. Let's take a space of 4 by 5. Initially place all ones. Okay. So from here 1 plus 1, 2. Take this 2 by 2. What is the maximum possibility in 2 by 2? 2 possible ways. Similarly, if you take this 2 by 3 matrix, 2 plus 1, 3. So before going into 2 by 3, we are using 2 by 2, the value that came from 2 by 2, which is 2. We are going to use that 2 plus 1, 3 value. 2 by 3 matrix, 2 by 3. How many different possibilities are there? 3 possible ways are there. So that's why we are going to apply dynamic programming here. We are going to save the values of sub-problems, and we are going to use that sub-problem value. Similarly, 3 plus 1, 4. If you take any 2 by 4 matrix, the total number of possible ways are 4 possible ways. Similarly, 4 plus 1, 5. We go with 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. Similarly, 1 plus 3, 4. 4 plus 6, 10. 10 plus 10, 20. 20 plus 15, 35. So the total number of possibilities that are available for a 4 by 5 matrix is 35 possible ways are there. Finally, we have to return this value. So we can do it in a m by n time complexity. Still there is some more optimization is there. We can reduce the size also. Here we are taking a space of m by n. No need to take that much of space. We can reduce the space also. How we are going to reduce this space is take only single dimensional array of number of columns. Initially place all ones. So we start with 1. 1 plus 1, 1 plus 1, 2. 2 is going to be saved here. 2 is going to be saved here. See, here we have written down, but actually think that this 2 is saved here. So 2 plus 1, 3. Means it is going to save 3 here. 3 plus 1, 4. 4 is going to be saved here. 4 plus 1, 5. 5 is going to be saved here. One iteration completed. What's the values in the single dimensional array? 1, 2, 3, 4, 5. The same values we are going to use in the next iteration. Initially start with 1. 1 plus 2, what's there here? 2. 1 plus 2, 3. 3 is going to be saved here. 3 plus 3, 6 is going to be saved here. 6 plus 4, 10. 10 is going to be saved here. 10 plus 5, 15 is going to be saved here. Coming to next iteration, we start with 1. 1 plus 3, 4. 4 is going to be saved here. 4 plus 6, 10. 10 is going to be saved here. Means using the single dimensional array, we can complete the task. No need to take the m by n space. That is what the optimization we are going to do here, using single dimensional array. So using dynamic programming is one of the way where we can go with sub problems values, and we are going to save those sub problem values and using that. And one more possibility is available using permutations and combinations. Hoping that you already have the basic understanding on permutations and combinations. If you are not good at permutations and combinations, please take our aptitude course. There permutations and combinations are discussed, so that you'll have better understanding on this. Coming to the second way, permutations and combinations, let's take 4 by 5 matrix. From this 4 by 5 matrix, see, if you want to start here, you want to go up to here. How many different actions you are going to take? Down, down, down. M lines are there. You are taking m minus 1 down options. Right, 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 right. In order to move here, m minus 1 down operations, n minus 1 right operations has to be taken. Down, right, down, down. How many downs? 3 downs, 4 rights. In order to move from here to here, you have to take m minus 1 down operations. Which way you are going to take is your option. So total how many possibilities are there? M minus 1 plus n minus 1 possible ways are there. Those are the options we have. See, that's why let's understand in one more way. See, first possibility, down, down, down. Green is taking down option. After that, right. So down, 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 right. Is this the only possible way? No. Down, right, down, right, down, right. Down, right. So take it as right. Right, down, right, down, right, down, right. Right, down, right, down, right, down, right. This is another possibility. So total m minus 1 plus n minus 1. Out of this, these are the possibilities. These are the total, these many number of options are there. Each place you can select either down or right, down or right, down or right. Out of this total, you have to select n minus 1 right operations, remaining down operations. How we write that? Using combinations. M minus 1 plus n minus 1 combination, n minus 1 right options you have to select out of all these places. These type of examples we discussed in our permutations and combinations. That's why we showed this type of example. So simply you have to write code to calculate this. M plus n minus 2 C n minus 1. If you take 4 right operations, n minus 1 right operations, remaining possibilities are down operations. So using permutations and combinations, this is the another way we can solve this example. But we are showing only coding for dynamic programming. You write the code because NCR coding is the basic level coding which we discussed how to write this code for in our basic examples, basic programming, C programming examples. So this is the code. Our code is available in our website. You can check the code and you can apply. You can download the code and you can execute the code. But our suggestion is try to solve it on your own. Then check for the coding. See, 2 loops m by n times. Each time we are going to do it this operation. Single dimensional space is taken. Initially, each space is taken as a 1. All the values in the list are considered as a 1. Hope you understand this example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.